Please welcome Alex Spinelli.
Hi, I'm really excited to be here. I'm Alex Spinelli. I am the Senior Vice President of AI and Developer Platforms for ARM. Just yesterday, we got this award. GitHub gave us Partner of the Year, their first ever. Super excited for that. And hopefully throughout this talk, you'll learn why. Today, what we're going to talk about is a bit about ARM, our vision, why you actually want to learn a lot more about us, and all the cool things we're doing with GitHub. And I brought some friends to tell the story. So what or who is ARM? So just by show of hands, who would say they're very familiar with ARM? OK, an OK amount. We're one of those companies that everyone's heard of, but not everyone knows all the amazing things we're doing. I joined about 4 months ago in a very new role to actually deeply engage with the software development community. We actually want to connect and learn how we can help you. So my job is to make sure your code runs great on all of the ARM platform. And what we're going to do is talk about the different ways we're doing that with GitHub. And we're going to show you all the ways that we want to connect and engage. And this talk is really an invitation to connect with us. And so I really encourage folks to come see us at the booth after the talk. So just a little numbers for ARM. We have shipped 300 billion devices out into the world. We're on essentially all of the mobile phones. We have full coverage in the major cloud providers, and there's 20 million developers working on our platforms. So ARM is in here, phones in your pockets. ARM is on laptops and Chromebooks. ARM is in data centers and cloud. Graviton on AWS, Cobalt in Azure, and Axion in Google are all ARM and offer amazing new TCO price for performance. ARM is powering autonomous vehicles and robots. And forgive the pun, but we are deeply embedded in IoT and microcontrollers. ARM is everywhere. We're even in these screens. We double-checked. These modular TVs are ARM-based. And the chips that are around your neck are also ARM-based technology. So Rene Haas refers to us, he's our CEO, as the most ubiquitous computing platform on the planet. And our vision is really to extend beyond this hardware footprint. We actually want to help engage developers in a couple of really critical ways where we have some deep expertise, and we're going to hear about some of those today. We want to help on performance and efficiency across any device, anywhere. We want to help your code move across devices, so compatibility and portability. And we want to help on advanced computational computing. So this is things like graphics rendering, gaming, especially on mobile, and of course, AI. And all of that comes with ARM's amazing price for performance and our legendary power efficiency. So we kind of think about this as one code base. One code base that can work across all of your different platforms, cloud to edge, and so that you have confidence that the code you write and you deploy is going to run great on any device. And we're actually going to talk about something pretty unique now, where with GitHub Actions and runners and ARM instances in the cloud, you can quantize and compile a machine learned model and actually move it straight from that instance in the cloud and deploy it onto a mobile phone. No emulators, none of the circuits that you usually have to go through to get that from an optimized and tested model out into a device. Super exciting stuff. And we're integrating with GitHub Copilot to ease that journey. So all along the way, you can get guidance and best practices and even cool code generation. So like I said, we're just getting started. We really want this presentation to be the beginning of a dialogue. So you're going to see us out in the marketplace in new ways. We want to show up for developers in new ways. And again, it starts today. Please come talk to us after. I'm going to hand off to Eric who's going to go through some of the exciting things we're working on directly with GitHub in this partnership. Eric?
Thanks. Thank you, Alex. Hi, everybody. My name's Eric. I'm really passionate about working with developers like yourselves, talking to you, hearing about the problems that you have, hearing about the solutions you create, hearing how ARM can help you and how we can bring our technology to you all more democratically, more easily, help lower some of the barriers of entry, barriers of adoption. So I'm going to spend a little bit of time with you to talk about how we plan to achieve Alex's vision, how we work with our ecosystem, how we work with GitHub, and the path forward, a little bit of history of our short but very fruitful partnership that led to the Technology Partner of the Year, which I'm personally very proud of, the whole ARM team is very proud of. And then I'll hand over to my colleagues to tell you a little bit about how you can take advantage of what we have today and start this journey towards this vision with us and engage with us, okay? So a little bit about our software ecosystem. ARM, as a computer architecture, doesn't go it alone. We have a very robust open source community and footprint in industry and developer footprint and a very large ecosystem that we contribute our engineering resources and code contributions to bring ARM tools into workflows, to bring our best practices to developers to help meet them where they're at, to bring performance optimizations into libraries and into frameworks that you all use and take advantage of, and do all of that hard work together with our ecosystem so that you, the developer, don't have to. So you don't have to even think about the underlying hardware, so that you can migrate to the ARM architecture easily if you want to take advantage of that lower price performance and total cost of ownership advantage Alex was mentioning in the data center, so that you can have the best experience on the ARM architecture to deploy your software easily. And ARM, as a ubiquitous platform and architecture, is showing up in clouds everywhere. As Alex mentioned, custom ARM silicon is showing up in the major ARM service providers, cloud service providers and platform as a service providers like AWS, Azure, and Google Cloud. And the adoption of the ARM architecture is fantastic. There are tremendous savings on the total overall cost of deployment for developers everywhere, whether in private cloud, in their own personal data centers using ARM servers, or in public clouds or hybrid clouds. And so in order to help galvanize that adoption and make the migration easier for developers, we find partnering with our community and GitHub essential to make the development process for migrating to ARM or making your applications multi-architecture or multi-cloud as easy as possible, and to make your experience as seamless as possible, so you don't feel any pain when you take advantage of the lower price performance that ARM has to offer. And so we've worked closely over the last 3 years with GitHub to help start bringing all of our ARM technology over to GitHub Actions and that environment. And we have a core mission of uniting the world's most ubiquitous computing platform with the world's largest developer community, so that developers like you can write once, build, test, and deploy your software everywhere that ARM is, and all those devices that Alex mentioned, regardless of where your application is. And if there's a migration of your workload from cloud to edge, that you have a build and test deployment environment, one repo, where you can start to do that work. And we started this journey, I think, 2 years ago at 2022 GitHub Universe. GitHub announced our partnership. You know, I've been working with GitHub a little bit longer than that, but we started by just taking our compilers and our other ID tools and some of our best practices for modeling ARM's architecture and models, fast models, functional models as a development platform, and integrating them natively into an image in GitHub Actions so that you, the developer, didn't have to come to ARM to get a compiler, have a deep licensing conversation, pay us a fee to get access to it, download and install our tools in a specific environment. We packaged everything up and made it available natively under Actions. And we set up some methodologies to really help embedded developers in the IoT landscape easily revolutionize and modernize their workflows and move into the cloud. And in doing that, we got tremendous feedback. We got a lot of adoption, but we also got a lot of asks for something more native. See, when you're compiling and cross-compiling and porting, even when you're taking advantage of virtual platforms, there's still something missing in the loop. There's still a need to migrate and port and translate the work you've done in emulation or in virtual environments over to the more native target that you have. And so last year, we took a use case where there was an immediate need for instruction set architecture parity that you have in an ARM server and an ARM server environment and the end devices, the ECUs in an automobile. And we shared our vision for cloud-to-car development. And we talked about how we could enable the software-defined vehicle of the future to help galvanize and keep the electrification of automobiles going, to help power the myriad of Waymos that you see all around that I took last night, and make the reality of software-defined AI-powered cars accessible to developers through a GitHub workflow, combining ARM servers that were announced last year at GitHub Universe under Actions natively and virtual devices. And this year, we're really pleased to report back to you on the adoption of those ARM runners and the progress in deploying them, and introduce a complete GitHub workflow that combines the work over the last couple of years. It takes images for Linux and Windows, where we combine all the tools together, make them available under Actions, with a native ARM runner that you can natively build and test and match with your deployment target, and the latest in AI assistance that Copilot, GitHub Copilot has to offer and that you've heard a lot about today, that is just very exciting, very compelling to everyone and makes all of our lives easier. And so you'll hear a little bit more about Copilot later, but let's delve into how ARM runners are changing the game for developers everywhere. Right? We started with an initial launch. We had a public beta in June of last year, and we got really, really great feedback that the tools and the approach of packaging up the tools and development experience under Actions with a native runner was the way to go. And in addition to just a unified developer experience, the price of the runner was a significant advantage because of the price of the infrastructure and the lower total cost of ownership for Microsoft and cloud service providers that host the technology. So then in September, just last month, we announced a GA. And the GA is for teams and enterprise plans. And then early next year, we expect to see the open source community have complete access to these. So we expect that the adoption of these runners is just going to continue to grow and grow. And we've already seen to date over 2,000 enterprises take up the ARM runners today and take advantage of the value proposition that they offer you, the lower price, the seamless developer experience, and start migrating your applications to ARM or support multiple architectures and deploy everywhere. The ARM runners cost 37% less than the other alternatives for Windows and Linux development. And that's tremendous savings for you as a developer, for your development team, for the deployment that you're going to have and the install base that you're going to deploy your services on. And at the end of the day, that's what we really care about, is making sure there's much more value in your experience of developing and writing and deploying your software on ARM. And that's what we've heard the most feedback on. And don't just take it from me. You can listen and hear straight from our users. Early seed startup took advantage and significantly improved build times from over 30 minutes to 4 minutes with the ARM runners. And that was just early in the private beta. That's right away they saw some of the benefits. And a AI application developer, open source Rust project, was able to save upfront effort with the setup and installation and management, as well as the week-to-week maintenance of having this managed ARM infrastructure to build and test their application on. So already we're seeing really great traction, and we're looking forward to bringing these runners to the open source community later on this year, early next year. So we're really thrilled about the adoption, and we're really interested in learning about the use cases that you have and the best ways to deploy them. So with that, I'm going to hand over to my friend Pareena Verma to talk about one of the more common use cases that's emerging with GitHub.
Thank you, Eric. Hi, everyone. I'm Pareena from ARM. I'm really passionate about crafting seamless developer experiences for diverse software that runs on ARM hardware. I'm an avid GitHub user myself. I'm very excited to be here today to talk to you about how we're utilizing the native ARM runners with GitHub Actions to streamline your MLOps workflows. Now, we not only live in a world of AI, but we also live in a world where we're inundated with acronyms. So, show of hands, who knows what MLOps stands for? All right, so I'm going to set some context here, right? MLOps refers to machine learning operations, and it's a set of practices that combines machine learning and DevOps for not only building, but also deploying and maintaining your machine learning models in a production environment at scale. It really bridges the gap between development and deployment because you're not only effectively building your model, but you're also ensuring that it's maintained and deployed in a way that provides and ensures continuous value generation. You know, just as the way we've seen DevOps provide efficiencies to traditional software workflows with CI/CD practices, I envision MLOps is going to provide the same benefits for the entire ML lifecycle. So GitHub Actions, as you know, is a really powerful tool that lets you automate your workflows right from your source code repository. For MLOps, you can use GitHub Actions to automate your entire ML lifecycle, all the way from data pre-processing to deployment of these models. The native ARM64 GitHub-hosted runners are a game changer for these ML workflows for multiple reasons. Performance. Now, these runners are built with the ARM Neoverse family of CPUs, which not only power these runners, but also power the ARM instances in the cloud. And they're built with vectorization technology like SIMD and Neon and certain architectural features in the CPU that are hyper-optimized to accelerate your ML algorithms. Now, these runners also typically consume less power, but more importantly, they're really easy to scale within your GitHub Actions environment, making it an excellent choice for your MLOps workflows. So in the cloud, ARM has been working with leading cloud service providers, as well as with the ML frameworks, to bring together a development environment where you can bring your optimized and ML workloads to life on your ARM-based hardware. So we've done significant engineering investments into these ML frameworks like PyTorch and ExecuTorch so that you have a faster and a seamless experience when you run your ML models with these workflows on ARM. So when you combine the fact that you have these native ARM64 runners available with GitHub Actions generally available with your team and enterprise accounts, and the ML frameworks like PyTorch and ExecuTorch just run faster on ARM and you're able to run these workloads, you've unlocked a really powerful solution for automating your machine learning workloads. It's particularly beneficial for MLOps and containerized AI applications. So let's pause and take a look at what the machine learning and MLOps software development workflow really looks like, right? And it's different from your traditional software workflows in the sense there's a tighter integration to the cloud very early on, not only for data collection, but also for deployment and monitoring. So if you start from the left of that image, you're collecting your training data all on the cloud using your ARM runners, right? You're then optimizing your neural network model. You're using techniques such as quantization and optimization for pruning. Once you have and this is all to fit into the constraints of your edge devices. So now once you have your optimized model, you then integrate it with the rest of your software, package it up into a binary, and then deploy it to your fleet of devices. Now, these fleet of devices are constantly monitored, but you can collect additional data to further improve the performance of your optimized model. The native ARM64 GitHub-hosted runners, you can leverage those runners to really estimate the performance of these optimized models directly in the cloud and seamlessly deploy it with the push of a click button to your edge devices. And that's really the key takeaway here in honing back into the point that Alex said earlier, right? No clunky workflows, no cross-compilation. Within the cloud, you've built your model, and the push, you can deploy it onto your phone. So we're really excited that tomorrow we're going to be hosting a sandbox session here at GitHub Universe, where we'll walk you through how to utilize these MLOps workflows in a real software project. It's anchored in an automotive use case. This sandbox session is really catered towards, the technical know-how for the interested developers who want to know the step-by-step instructions, code samples of how to implement these MLOps pipelines with PyTorch and GitHub Actions. I will be there with my co-presenter, Jason Andrews, who is a distinguished engineer at ARM, but more importantly, he's a really passionate educator and wants to empower all of the ARM developers and the developer community at large to master your software development on ARM. Over to Jason for the rest of the exciting updates.
Thanks, Pareena. Hi, everybody. I'm Jason Andrews, and I really love to write and to teach people about software development on ARM. I just want everybody to learn more and to be able to move faster in all the things that you do. So I'm happy to be here with you today, first time at GitHub Universe, and I have a couple of things that I want to share with you. First thing that I want to share is that I am proud to announce that ARM is extending GitHub Copilot. So you can probably sense from the activity here, there's a lot of momentum behind ARM right now. And developers are really interested to take advantage of the performance, efficiency, and cost savings. So maybe you are a cloud developer and you're migrating cloud applications or services over to ARM-based instances so that you can save costs. Or maybe you're using GitHub Actions with ARM runners because you want to build native versions of your applications and you want to run those during your testing phase without instruction emulation. Or maybe you're an automotive or IoT developer and you're targeting ARM hardware in your project. So regardless of the case, we really want you to have a great experience with Copilot. And so to do that, we're building a Copilot extension that will bring all the knowledge of ARM together and give the right context for you in Copilot. Now, there's two important things to do that. So in the Copilot extension, we want Copilot to be fully aware that you are developing on ARM and for ARM, and you love ARM. That's very important because it filters out a lot of the useless information that you don't need. The second thing is to have the up-to-date data, right? So we know things are changing all the time. New content is available. New hardware systems are coming. New software becomes available. Different stacks for AI and ML. Constantly, we're optimizing software. So as a Copilot user, you want to have all of that information up to date all the time. So by setting the right context and delivering you the timely and accurate information, you're going to get the best experience with Copilot. So by extending Copilot, we want to enable all of you to learn more and to move faster. So let's take a look at a short demo, and we can see it in action. OK, so this is going to be a Copilot demo, and I'm going to just compare and contrast those two main points that I was talking about. So first, let's say as a cloud developer, I'm going to ask Copilot a question about how do I install the Azure CLI. OK, so we'll put that into Copilot, and we'll get the answer back. And you'll see it's got some instructions, but it's for a Mac. I forgot. I'm working on Linux in a cloud machine, so let's change that. So we're going to ask, how do I install on Linux? So I get some good-looking instructions there. It's using Linux Package Manager. Seems all fine, but you'll notice one small point, wrong architecture. OK, so how do we fix that? let's try a different approach and ask the ARM extension the same question. How do we install that Azure CLI? Again, we'll put that into the ARM extension. And this time we get something completely different, right? We get a curated experience which re-emphasizes the fact that you are an ARM developer and you are running on an ARM server in the cloud and you want to install the Azure CLI. And then it's going to show you two different ways to install that software, one using curl and then another one using Python pip. Both those work great and they're fully tested. And you'll see at the bottom of the screen there's a link to the exact install instructions that you need if you want more information. Okay, so that's the type of experience we can bring with a curated environment. Okay, let's try another question. So what are the flags for large system extensions on Rust? So this is an architecture feature for ARM for systems with many CPUs and optimizing atomic performance. We get something, but it's not really at all about the ARM architecture. Again, very generic. So let's ask the ARM extension how to install or use those flags. And this time, we'll get exactly what we're looking for. Okay, so we'll get some information explaining that if you're on the Linux architecture ARC64 and you use the target feature there plus LSE, you'll be good to go. You'll get that best performance. Okay, let's try another thing with Copilot. What about multi-architecture images for Docker? Very common situation as people migrate to ARM, they want to have multi-architecture images. So again, Copilot has some information. It's a little bit mangled there in terms of instruction emulation and using a manifest. And let's move over to the ARM extension and see what we see. So in this case, what you'll notice is we get a very clear differentiation of what our options are. So we have options for instruction emulation. We have a Docker manifest command, or we can use a cloud service like the Docker build cloud. And there's links to each one of those showing you specifically how to do that. Okay. Now let's ask maybe a follow-up on that. We could ask about the Docker manifest command. How do we do that? How does it work? And using this ARM extension, we'll get a clear example of how we can use two different machines, each with a different architecture, and then we can create a manifest that brings those two images together, and then we can push that to our container repository. And then you'll see at the end there's 4 quick steps to make sure you fully understand what's happening here. Okay, next question. Let's ask about what kind of hardware has bfloat 16. New data type, very important in AI and ML. We see some results. There's a Google TPU, an NVIDIA GPU. But remember, I'm an ARM developer. So let's ask the ARM extension, which hardware has bfloat 16 support. And when we see this, we get a list of ARM processors, probably Graviton 3 with the Neoverse V1 might be the one you're most familiar with. That'll give you the highest performance. And you get more information on how to do that. And then we'll ask a follow-up question, well, how do I know if my ARM system has bfloat 16? I'm running Linux, I don't know. So we can check proc CPU info and look at the features, and you even get a small C program that you can use during runtime to detect the feature. Okay? So last question to wrap up the demo. Let's ask about the benefits of some other architecture. So when we ask that, of course, there's no answer, right? We're focused on ARM because we're ARM developers. So again, I just want to kind of summarize there that the context that you set and the data you use, that's what makes your Copilot experience great. And that's what we want to deliver for all those ARM developers out there. Okay, so today we've shown you a complete flow with GitHub Actions. We talked about ARM runners, how you can build executables that you can run and test in the cloud with no instruction emulation. And we talked about GitHub Copilot and the extension that we're building for that. So the Copilot extension will come into the GitHub Marketplace in December. Eric mentioned the ARM runners are available now, but early next year we'll have those available for all projects, including open source projects to use. And yeah, those are those two. So I want to leave you with a couple more things before we go. The first one is going to be learning paths. So learn.arm.com, this is an extremely important URL. I would highly encourage everybody to go there now. So at learn.arm.com, we have a variety of technical articles. So we call it a learning path. A learning path is a technical how-to. that has all the detailed instructions that you need to do various software development tasks. They range from server and cloud all the way through to microcontrollers and pretty much everything in between. Now, learning paths are actually published on arm.com, but the most important thing about them is that it's really a community project. And anybody can contribute to learning paths if you have information you would love to share with our software developer community. So you can probably guess where you can do that. Learning paths are hosted on GitHub. So if you go to GitHub, we have instructions on how to do that and possibility for you to contribute material about how to develop on ARM. And all the learning paths will have your name and link to your GitHub profile, and it's a great way to share. So anybody out there who likes to build things, you like to share, this is a great platform for you to share your work with all the different ARM developers out there. Okay, one more thing before we go. We have a developer program. We call it the ARM Developer Program. Definitely take a look at this. So this is a place where you can connect with other developers on Discord. You can go to developer events and get access to additional developer resources. So you can sign up for that today, arm.com/developer program. Yeah, it's free, easy, very quick to join. So I encourage you to do that. Okay, thanks everybody for coming. As I think we all mentioned, we would love to hear more from you about what you're doing in your software development projects. Definitely encourage you to try ARM Runners. As Pareena mentioned, we're having the sandbox session tomorrow. If you come to that, you'll see the MLOps workflow in process, and you'll get some hands-on experience with ARM Runners. So thanks everybody, and have a great universe.
Thanks, everyone.